All right, Algebra 1, good afternoon, and welcome back to our continued distance learning. I hope you had a great spring break. I hope it was restful. I hope you got to do something enjoyable, and I especially hope that if you were missing any assignments, that you had that opportunity to catch up on those. If you haven't, all of the assignments on Alex are still open until the 17th. So please, please, please try to make some time to get those done. I know a lot of things have been said about our current situation and about your grades, and just to play it safe and not to miss out on any opportunities to get points, I would love it if you guys would make sure to get your assignments done regardless of what's going on. Get your learning in. You'll be moving on, many of you, to geometry next semester, and I want you to be as prepared as possible. So please continue to do your best, and also know that everything that you're completing now, even if your grade was low before we left, your grades can increase. So definitely make that effort to get your work done. Okay, so please try to not get mad at me, but before we left from school due to this virus pandemic, we had discussed you doing an end of unit. And you never got the opportunity to do that. We finished our mid-unit right before you left. We had done a practice end of unit. We had done a lot of work trying to get us prepared to take the end of unit, which was meant to be the same as the mid-unit and pretty much just like a mid-unit retake. But unfortunately, a lot of you guys didn't get an opportunity to do that. And we've moved on into unit 3. But looking at your mid-unit grades, I thought now would be a great opportunity for you to do the end of unit, to bump up your old mid-unit scores, and to bring your overall grade up, up, up. So that's what we're going to take care of this week. So we're going to kind of pause what we're working on with unit 3, although it is kind of still related because we're working with lines. But we're going to focus on the end of unit. And what I've done to help you do that, to help you prepare for the end of unit that will be due on Friday, I've made an Alex assignment. So all of your tests from now on will be done through Alex. That's why it makes it even more important for you to do your Alex homeworks, because it gets you to practice with the technology. Okay, so you'll have your end of unit on Friday, but let's get some end of unit practice. So today's going to be a quick recap. The rest of this video, hopefully you've watched up until now and you've got some information about the class. The rest of this video is going to be a recap for your end of unit. So pretty much what I'm going to do is I'm going to go through your practice end of unit, which I have posted on Alex. I'll post that also on Schoology so you know that it's due, but the actual material will again be through the Alex program. Okay, so if you want to stop here and go on to Alex and try the homework by yourself, feel free to try the practice end of unit by yourself. You go ahead and do that. And then if you're stuck on anything, you can refer back to this video for a little help, for a little support. You can always send me screenshots of your work. Some people have been doing that. They send me a screenshot of the problem that they're stuck on and I can help with that. But otherwise, we will have a Zoom meeting at some point. And you know, I've been referring to period 6 because I'm making this video on a Wednesday, but period 3, the same thing applies to you, except that your test will be on Monday. But if you have any questions, feel free to message me and we can meet on Zoom and we can talk about that and get those things done. Okay, so again, if you want to stop here and practice on your own, go ahead. If you'd like to continue with me to do some practice together, continue watching the video. Remember that my Alex questions are not going to be the same as your Alex questions because the numbers will be different, but the general topics and the general standards are still the same, and you will be tested on the same material for your test. Friday for period 6, Monday for period 3. Okay, so I'm going to go ahead and jump over to Alex. This is my student page for Alex. So those of you in period 3 or period 6, you should be seeing about the same thing. Okay, if I look over here on the left, I see, I'm super behind on my homeworks. I should have done homework 7, 8, and 9. They're still open for me, so I can do those and get my credit and not leave them as missing assignments in Schoology. That would be terrible. So I can go ahead and go back and do those. But for today, I'm going to practice. I'm going to focus on the practice end of unit. And this is supposed to emulate what you would be seeing on the actual end of unit at our next class session. So notice that you have a time limit, okay? And this time limit is designed so that you have to sit down and take the test in one full sitting, okay? Just like in the classroom, I don't expect you to take the full 2 hours and 30 minutes if you don't need them, but they're there just so that you have the time to do so. For this end of unit practice, you have unlimited attempts, just like with the regular homework. So say you miss a few and you get like a 60% on this homework and you don't want a 6 out of 10 in Schoology, you can do a quick retake, redo the problems that you did wrong, and then get points for that. So please take advantage of that. It really is possible for you to get 10 out of 10 on all your homeworks as long as you're willing to put in the effort. So hopefully you're doing that. So there are 11 questions. I'm starting my first attempt out of unlimited. Okay, so I'm gonna go ahead and start here. All right, so again, I'm recapping. If you have your notes with you, feel free to use them. Now is the chance to do so. You took them, so go ahead and use them. So a line passes through the point -8, 1, and has a slope of -5/2. So I'm going to go ahead and write an equation, and they're asking me for an equation in point-slope form. So in case you forgot, let's annotate here. Let's see if I can, oh, I can. Great. So in case you forgot, our equation for point-slope form looks like this. Okay, where it is my job to fill in this y1, this m, and this x1 with the information that was given to me. Okay, so if I remember from my notes and if I remember from class time and all our work together, here's x1, here's y1, and here's m. So really it's just a matter of me plugging things in where they belong, okay, putting them in the correct corresponding spot. And so what that looks like is y minus, y1 is a number 1, and then equals slope. Our slope is -5/2. And then x minus our value for x1, which is a -8. Now watch out here, and they're going to give you negatives often to test this on you. These two negatives, we all know something special happens here, right? We all know those become a positive. So my final answer is going to look like this. And I can leave it like this because this is point-slope form. Okay, it doesn't ask me to switch it to the y equals mx plus b form, to our slope-intercept form. So we can actually leave it like this, and I can fill in my work here. So let me exit my annotation. And let me go ahead and put in my answer. So y minus 1 equals negative, we've got a fraction here, 5/2 times x plus 8. All right, so we did a good job, got that correct, used our formulas accurately, and now I can continue on. Let me clear these annotations here. So we can continue. All right, now we've got functions, f and g. Okay, this is us testing if we can use appropriately our function notation, which I'm happy to say many of you are very, very good at. So let's go ahead and work on that. Again, I'll bring up my annotation here so I can show a little work. All right, so starting with f, because they want f of -3. So I've got f of x, 2x cubed plus 6. Now, Alex unfortunately doesn't provide me the opportunity to pick the equation, so you are going to see these cube functions a little bit. Try not to let it stress you out. Feel free to use a calculator. You're allowed to use calculators always. So, all right, let's work through this one. So I've got x, and I know I'm going to be substituting that in for something. Okay. And in the problem, it's asking me to go ahead and substitute -3. Here it is, -3. That's what they're substituting. So I'm going to put f of -3 equals 2 times that same thing, -3, except it's cube. So try not to let that stress you out too much. Cube just means I'm going to multiply -3 3 times. Okay, so f of -3 equals 2 times. So now -3 cubed means -3 times -3 times -3. So in case you weren't sure how exponents work, that's how exponents work. There's 3 of them. And so I've got f of -3 equals 2 times, and I'm going to use my mental calculator to get -27. Okay, and as I continue my work here, -3 equals 2 times -27 is a -54. And finally, my final step, I'm pretty low on the screen here, good thing I'm on my last step, is a -48. Okay? And again, a lot of those steps I do using my calculator in my brain, but feel free to use the calculator that you might have on hand. And so now, let me exit this. I'm going to go ahead and fill in my answer, which is -48. Okay, I would do the same thing with g of x, but for the sake of your time, I've already done an example for evaluating functions, so I'm going to move on to question 3. Oh, they don't let me move on. This would be a -13. Okay, so moving on to question 3. And again, feel free to fast forward or skip around to the problems you needed help with. You don't necessarily have to stick to everything that, every single problem that we're doing if you already know it. This is a review. So this one is a word problem. We love word problems. So just to kind of recap about slope-intercept form. So y equals mx plus b. Okay, let's review some things about that. First of all, we've got this m here. And if we remember, m is our pattern. Okay, so how are things changing? That's going to be our focus for m. On the other hand, for b, and let's do b green, b is our starting value. You know, some sort of base amount, initial amount. Initial is a good math word. Okay. And so thinking about this problem, Alan is a software salesman. His base salary is $2,500. And he makes an additional $90 for every copy of English is Fun that he sells. Okay, so at the beginning of his work time, he makes $2,500. Okay, that is his base salary, his initial salary. That's what he gets just for showing up to work. Once he shows up to work, there's a pattern happening here. He gets $90 for every copy of English is Fun that he sells. Okay, and this word every, okay, this one right here, this word every is really important because that's the word that usually indicates to me that I've got a pattern happening. $90 every time he sells a book. Okay, and so now that I have those two components that I need for my equation, I can go ahead and type my equation in. Y equals m, that's our slope. We have m now, it's 90. Okay, and you know what, let me continue reading the instructions because I missed a part here. Let P represent his total pay. So now that means I'm not going to be using Y, I'm using P for his total pay. Okay, they're using different variables here. So Y is his total. Let's make those connections. Oopsies. Okay, so I'm gonna go ahead, sorry about that. I'm gonna go ahead and make, let me go ahead and add in a little more information here for the variables that they're asking for. So they want P to represent the total. So this is usually our total. Okay, so I'm gonna use the letter P. And they also want us to use N to represent the number of copies. So that's X, right? Because every copy that I sell is going to get me $90. Okay, so just keeping those things in mind because they are using other variables. Now I can go back to my equation and write P equals M, which is my pattern. That was $90 per book. N is the number of books. And then of course he starts out with $2,500 for his salary. Okay, so just a few pointers on this one. If the letter is capital that they're asking for, we must write a capital letter in our answer. Okay, because capital N in math is very different from lowercase n, you know, just as it would be in English. But if you use a different case for your letter, then it represents a different variable. So it's really important that if they have a capital P, you use a capital P. If they use a capital N, you use a capital N. Okay, so just keep those things in mind. Finally, they want to know how much money will I have total if Alan sells 21 copies. So let's go ahead and try that out. So I'm looking for P, which is my total. My $90 is my pattern, but this time, instead of writing N, I know how many, you know, N is the number of copies. We know how many copies he sold now. He sold 21. That's what they're asking for. So I can fill in 21. And then his base salary. Okay. So again, I'm going to my trusty calculator. Equals 90 times 21. That's 1890. And then plus the base salary, which is equal to $4,390. All right, so when they ask total pay if Alan sells 21 copies, I can now come over here and type in $43.90. Okay. So take those word problems a little bit at a time, really break them down, look at your variables. They will take off points if you put Y instead of P as they asked. So this is really important that you're following instructions. All right, moving on to question 4. Find the slope of the line passing through the points. Now, I had some people in I believe it was period 3, but I could be wrong. It might have been period 6. Well, quite a few of you were using a new method, which I thought was great for finding slope. So if I have a table, okay, and I've got -8, -3 as one point, and -3, 4 as my second point. So I just took the information, right? X, Y, X, Y. I also know that slope is the change, right? This delta means change. Change in Y over change in X, right? Your rise over your run. So if I can figure that out, then I'll be good to go. And a lot of you just find the change in Y and then the change in X, which is great. So how do I get from -3 to 4? I add 7. And to get from -8 to -3, I'm adding 5. Be very careful using your calculator for these ones. Sometimes a number line is really helpful. And so now I can write my slope. 7 over 5. Can't simplify. Those are prime numbers. So we are done. And I can come over here and ask for a fraction and type 7 over 5. All right, so far so good. We're almost halfway through this homework assignment. Let's clear our work and continue on. Okay, this one's very similar to your function notation. We're just filling out a rule for this linear function. So to kind of, I'm going to just do the first one and then we'll move forward. I've got y equals -5. But this time, I want x, right? Here's x. I have x, I just didn't have y. So let me plug in x. The first one is a -2. And then +1. I'm going to finish off my equation here. And I'm going to do my math very carefully, starting with this guy, because multiplication first. -5 times a -2 is a +10. And y equals 11. Okay, and I can do that for the rest of the table and just kind of fill in whatever it is they needed. So I've got 11 here. I've got 1. I've got -9 and -19. Okay, so that would have required a little bit more work probably on your part to get those rows finished. Hopefully by now you guys are using some sort of notebook or paper to do scratch work. In no way do I need for this to be mental math. Okay, so please make sure you have work and you're working on those off to the side. All right, here's the next one. Don't think I'll have to annotate for this one. Now we have to graph a line. And so to graph my line, I'm going to start by plotting a point. So this tool right here allows me to plot a point. And since this is point slope form, I'm going to start with that now. Looking at this equation, if we remember correctly, our point slope form looks like this. Y minus y1 equals m times x minus x1. Okay, so with that information in mind, my x1 is over here at the end. That's a positive, which means x1 should have been a -3 because minus -3 would have given me the +3. So just to kind of write that out, I've got y minus 3 equals -1/4 x minus -3. And again, that's because these two minuses here make a plus sign. So with that information, I know that this is my x1, this is my y1, and this is my m. Okay, so I can come back down here and put y1. And just to be clear, y1 is just the 3, x1 is the -3. And I can scroll down and put the other point. Now you can also just come and click on here to make the point, but I kind of like the point plotting tool. It really helps me see and make sure I don't make any mistakes. Sometimes it's kind of hard to work with this little graph anyway, so it's kind of cool. And then I'm going to use the line tool. So I'm going to start with the point that I just made. When I make my second point, I'm going to very carefully use that -1/4. So let's try to remember what that -1/4 looks like. So I have two options, right? Because remember, slope is rise over run. So I know I either have a triangle that looks like this or a triangle that looks like this. Okay, both of them are 1/4. A y change of 1 and an x change of 4. Now the thing that helps me the most to figure out which triangle I should be using is this negative right here. Okay, and if you remember from a long time ago when we were in the classroom together, negative means I'm walking down the hill from left to right. So here's my little person. He's going up, so it can't be this one. Here's my little person again. He's going down, so this is a negative slope. So that means I want this triangle right here. So when I make my little triangle for my point, I'm going to go down 1, to the right 4, and there's my line. Okay, and so again, this might take a little getting used to as far as using the tools, which is why it's important to continue doing the homeworks. If you have any questions or have any issues, feel free to contact me and I can help you with those. All right, so continuing on. Okay, so for this problem, we've got an equation that is in y equals mx plus b format. And for those of us keeping track of our vocabulary, that is our slope-intercept form. And so what that means is b is my y-intercept, and m is my slope. It's even in order, right? Slope-intercept form. So let's break some of these things down. Let's start with y-intercept, because y-intercept I like to think of as my starting point. Okay, start here. So in this question, or this equation, our starting point is a -8. And so what that means is I'm going to scroll down here a bit, if I can. I'm going to scroll down a bit, and I'm going to look at this equation, and I'm going, or this coordinate plane, and I'm going to graph my -8 right here at the bottom. Okay, so there was my -8 for my slope, for my intercept in this equation. For the beginning part of the equation, just to rewrite it because we lost it at the top of the page, we've got y equals 3x minus 8. So 3 is my slope. And some of you might still be thinking, well, 3, okay, I know slope is rise over run. So if I've got 3, this has to be the rise. But where's the run? Right? And so many of you, and I think this is a great strategy, many of you like to put a 1 underneath. It doesn't change the value of 3, but it does offer a placeholder for run. So I can be confident that that's the run now. And so now I have two options, right? I've got a triangle that faces this way, 3 over 1. And I've got a triangle that faces this way, 3 over 1. And I know that my little person that we talk about in class, this one going up means he's got a positive slope. And this guy going down means he's a negative slope. And since 3 in our equation is positive, I'm going to go with this guy. Okay, now, just so that we know, trying to draw the slope triangle down here might be kind of hard because it goes off of the grid. So what might be a better option for me is to do that same triangle just this way now. Okay, that way it fits on the grid. It's still a 3 over 1 triangle. I haven't changed that. The points are still on the points that I was given. So Just as a little helper for you, we're starting at -8. There's our slope of 3, and we can move on. Okay? So work very carefully on these. Don't rush. If you've been following along with the video, it's only been about 25 minutes, and we're already on question 8. And that's with me sitting here and explaining every little bit of the test, so don't feel rushed through this. 2.5 hours is plenty. All right, so let me clear out this work here, and let's continue on. All right, same question, except now we've got a nice slope of -1/5, so you've got your rise over run. So I'll let you guys work on that one on your own. All right, number 9. Number 9 is asking about arithmetic sequences and whether or not we can determine the common difference. Okay, so really what all that means, and this is the beginning of our unit 2, so I can understand why this might be a little old for us. But really what that means is, does this thing change by the same amount every single time? And that's linear equations, right? We learned at the beginning of this unit that arithmetic sequences are very similar, or they are linear equations because they have a constant rate of change. So as long as we have the same difference each time, then it's arithmetic, and we found the difference D. So let's go ahead and check that out for this first one. So looking at this one, to go from -2 to -8, that requires me to subtract 6. Okay, again, a number line is really helpful for this. If you're good with negatives in a calculator, that works too. Going from -8 to -32, now that makes things a little different. We've got -24 for that one. So immediately I can stop because this is not arithmetic. -6 is not equal to -24. So I can stop and let Alex know that this is not an arithmetic sequence. Okay, let's try the next one together. To go from 33 to 26, that's a -7. Okay, again, I'm doing mental math. You guys can use calculators, number lines, whatever helps. Going from 26 to 19 is -7. So it's looking good so far. All the same. But 19 to 12, again, that's -7. So this one's arithmetic. We subtracted 7 every time. So now I can go to the arithmetic button. I can tell them that the common difference is -7. Okay, I didn't have to type anything in this one because we decided it was not arithmetic. Okay, let's clear this work, and I think that kind of takes care of this type of problem. Just so that we can continue on, I'm going to go ahead and say that this one is arithmetic also because we are adding 4. Okay, moving on. This one we want to determine whether things are functions. Okay, think about the vending machines that we made, the machines that were good versus the machines that gave either a random bag of chips or too many chips at once, right? Somebody was suffering if the machines were broken. So looking at that, pretty much we're looking to see if one domain offers one range. If I have one domain giving one range, then it's a function. And immediately I can see from star and desk that this is not a function. And just to repeat why, if I selected a star, I would get a -7 and a 0. That's equivalent to putting in the code A3 in our vending machine from our notes, plugging in A3 and either getting hot Cheetos or Fritos. If I don't like hot chips and it randomly gives me hot Cheetos, I'd be an upset person. Wasted money. So this is not a good machine, and so it's immediately not a function. Same thing over here. I plug in a -7, and what comes out? One of these 3 things. That's unacceptable. If I plug in a number, I want only one thing to come out. I want to be sure of what I'm going to get. And right now, it's random. I have no idea what I'm going to get. So again, not a function. These look a little weird because they're using letters, but they work the same. Okay, looking at, I can just focus on my x values here. So I've got C, Y, A, N. So if I really wanted to see this as a mapping, I can go C to N, right? Because this is our input, output, input, output. I've got Y going to C. A goes to N. We have an N already. That's okay. There's still only one arrow coming out. And N to N. N's popular. So all that's fine. This is a mapping that's okay for a function because all of the inputs have only one output. They all had various outputs, but again, going back to our vending machine analogy, those are like the machines where they have 2 or 3 rows of hot Cheetos because they know how much you guys love hot Cheetos. So they've got row A with hot Cheetos, row B with hot Cheetos, and row C with hot Cheetos because that's their hot seller. Okay, so this is fine for a function. We can say function here. Let's look at the next one. Again, we've got to be careful. We're looking at x's, and if I'm just looking at the list, I've got a 4 and a 4. This 4 gives D, this 4 gives A. So immediately I've got some sort of issue. Making a mapping for this one, I've got 4 goes to D, 3 goes to A, -8 goes to A, and 4 maps, or I'm sorry, I don't even have to write that 4 because I have a 4 already. 4 maps to A. And there's the problem, right? The problem's right here with this double arrow. When I select 4, I have the option of 2 things, and that's not okay, so we've got not a function here as well. All right, and with that, it brings us to our final question, question number 11, which is asking us again about functions, but this time we've got graphs, and we're trying to decide, is it a function or not, yes or no? And so if you remember, there's something called our vertical line test. Okay, vertical line test. And what I'm looking for is if I put a vertical line anywhere in this graph, here, 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 does it only cross one time, right? So on this line, it only crosses once. This line only crosses once. Once here, once here, once here. So we're good. That one only crossed one time at any given red line, red vertical line. And so I can select, yes, this is a function. Some of you probably already know what's going on with the second one, but let's try the second one. If I put a line through this one, sorry, it's a little crooked. We're good so far, right? It only crossed one time. But what happens if I put a red line here? It crosses twice here, right? And that's not okay. That's not a function. Okay, we're sad about that one. So we can select no for graph 2. How about graph 3? Graph 3 shows discrete data. Discrete meaning it dots, if you remember from our notes. Uh-oh. Immediately I have a problem. This one doesn't have a problem. Nor does this one. This one does, though. But really, we only needed the first problem. As soon as I run into some sort of issue with my vertical line test, it's not a function anymore. All right, so moving on. Let me clear my work. This one's not a function. This one is a function. This one's not a function. Okay, so work through these problems carefully. Slowly, take your time. Each question is worth 1 point, and I give you all those points in your gradebook. When I'm done, I can submit, and it gives me my score. We did a great job. We worked slowly and deliberately, and we got 100%. If I had gotten one incorrect and I wanted to retake that so I could get 100%, you can go ahead and do the quick retake so you can get back the points that you might have lost on your first try. And, please don't feel like you're losing points if you take multiple tries. Okay, if anything, as a teacher, I'm happy to see that you're doing more than one try. It means you care enough to do the problems again. So feel free to retake them, get that 100%. Please take the time to do this practice in preparation for your end of unit test. Okay, and I'll give you more instructions for the end of unit test on the day of your exam. So again, take some time to practice. Message me with any questions or concerns. I hope that you're all being safe, and I miss you all very much, and I hope to hear from you soon. Do your best. Bye-bye.